Hello. Okay. So in this lecture, I'm going to discuss about a sequence detector, which will be detecting the sequence of 1001 using Mealy non-overlapping method. Okay. So in order to understand this problem, we need to see what are the steps we need to follow to design such type of FSM. Okay. Finite state machine. Okay. So first step is we have to draw the state diagram. Okay. So how to make the state diagram? That is important. So in order to understand the state diagram, we need to first understand how many states should be there in the state diagram. Okay. So in case of Mealy non-overlapping, you need to understand or remember, in case of Mealy overlapping, the number of states will be equal to the number of bits given in the sequence. Okay, so in this problem, how many bits are there in the sequence? 1, 2, 3, 4. So number of states will be 4. That is the basic thing you need to understand. Okay, so as we have decided the number of states is 4, so you can draw 4 states A, B, C, D. And after that, what is the next job we have to do? We can make some arrow the rightward direction and n minus 1 number of bits of this given sequence we can write on the top of these arrows. So n minus 1 means in this problem n equal to 4 means 4 bits are there. N minus 1 means 3 bits. First 3 bit we can write on the top of this arrow 1 0 0. Okay, last bit that will do later on. Some operation will do for the last bit. Okay. Now the next thing what you need to understand is for each of the state, you need to consider the input of 1 as well as the input of 0. Both the inputs you need to consider for each of the state. That is the thing you need to remember. OK, so for each of the state, we need to consider input of 0. We need to consider input of 1. OK, now in this case, you need to remember another important thing. State A is known as research state. You can note it down also. State A is known as research state. So for this state, whatever maybe the remaining input is left, for that state you need to make the self loop. That you need to remember for state A. OK, so we'll discuss each of the rule, what you need to follow in the state diagram one by one. OK, so first of all, for A, you need to check which input you have already used. You already used the input of 1. Means if you have the state A and if you are having the input of 1, it means you need to go to state B. Now, what state you didn't consider for A? You didn't consider the input of 0 for A. Now that you need to consider. So if you consider the input of 0 of A, input of 0 for A, you need to make self loop. As I already told, A is reset state. Whatever the remaining input is left, whatever it may be 0, it may be 1, but you need to make self loop for that for the reset state. So as the remaining input is 0, you need to make the self loop. OK, now for B, state number B, we need to decide what we have to do. So for B, if you can see here for B, what you have already used, input of 0 you have already used. So what does it mean? If you are in the state number B, if you have the input of 0, you have to go to state C. Now what you still didn't consider? You didn't consider the input of 1. So for input of 1 from B, where you need to go, that you need to decide or determine. How to decide that thing? So for that, you need to follow some rules. So I will do something here, but these are not the part of your state diagram, but still I will write here to make you understand. Now, if you see closely here, what B is doing? B is detecting the sequence of 1 actually. B state is sequencing that is detecting the sequence of 1. What about C? C is detecting the sequence of 1 0. What about D? D is detecting the sequence of 1 0 1 1 0 0. Sorry, 1 0 0. OK, we can write down these things for each of the state in the square box. So B is detecting sequence 1, C is detecting 1 0 and D is detecting 1 0 0. That we have written below of each of the state in square box. Okay. And these square box are not the part of your state diagram. But why I have drawn these things to make you understand this state diagram. Okay, fine. Now, so what I was discussing actually for B, what we have already considered 0, we have already considered means input of 0 we have already considered for B. So what input we didn't consider? We didn't consider the input of 1 for B. So if you consider the input of 1 for B, where you need to go, that we have to determine or decide. Okay. Now, how to do? So for, as you know, B is detecting sequence of 1. So that you need to first copy here. So whatever you have written in the square box, that you can copy here in the left side. And in the right side, what you need to do for B, what input still you didn't consider, that you need to write in the right side. So for B, you have already considered 0. What you didn't consider, that is 1. So that 1 you can write in the right side. Okay, that right side 1 you need to compare with the square box 1. Understood what I said? The square box 1 has to be compared with the right side 1. And from where I have written this right side 1, for B, what state you didn't consider, sorry, what input you didn't consider for B still now, that I have written in the right side. So that one you have to compare to the in the inside one, means whatever it is given in the square box. Are they same? Yes. So if it is same, then you need to make the self loop. Suppose if they are not same, suppose the remaining state was 0. For B. In that case, 1 is not matching with 0. In that case, you had to do the direction. You had to give the direction from B to A. Means you had to go to the reset state. Understood the rule? What I said? If this one is matching with this one, you have to do the self loop. If that doesn't match, you have to go to the reset state. So for this particular problem, these are matching. So we have done a self loop. But in some problem, if that doesn't match, then you have to go to reset state. Understood the rule? Now, follow the same rule for C. So for C, whatever we have written in the square box, that you copy, paste here. And after that, for C, what input what you didn't consider till now, that you have to write in the right side. OK, so for C, what you have already considered 0. What you didn't consider, you didn't consider the input of 1. Because you have to remember one thing I told, for each of the state, you have to consider 2 input. One is input 0, other one is input 1. So for C, you have already considered the input of 0. What you didn't consider, the input of 1. That I have written in the right side. Fine. After that, what you need to do? You have to make a pair of these 2 bit and you have to make a pair of these 2 bit. These 2 bit you need to compare. Are they same? No. If they are same, you need to make self loop. If they are not same, then you have to take the extreme right side bit. What I told, if they're same, then you have to do the self loop. If they're not same, you have to take the extreme right side bit. As it is a single bit, you need to compare with the single bit state. So single bit state, you know this in the square box 1 is written, this one is matching with this one. As they are same, you have to do this direction, means from C to B you need to go. If they are not same, in that case from C to reset state you have to go. OK, what I told, if this one is matching with the single bit state, you have to make the loop from C to B, because this one bit state is representing B only. So from C to B you need to move. If they are not same, you have to go to reset state. From C to A you have to move. OK. Now come to the last one. Now we can remove these things. We have already found out for these things. Now for D, you have to remember one thing. For Mealy non-overlapping, when you are coming to the last state, means state number D for this particular problem, you have to follow some different rule, because you know up to state number C, we have followed some similar type of rule. But for D, you have to follow a different rule. What rule you need to follow? For D, if you can see here, we didn't consider any of the input. We didn't consider the input of 0. We didn't consider the input of 1. Is it yes or no? Yes. So whatever may be the input, it can be 0 or it can be 1. In both the cases, if you consider, then you need to go to reset state. This is the rule you need to remember in case of Mealy non-overlapping method. For the last state, whatever may be the input, it can be 1 or it can be 0. You have to come to reset state. This rule you have to remember. OK, fine. Now, in this state diagram, most of the things we have done. One thing still left. We didn't write the output. So if you know in this Mealy FSM, how we write the input and output by using this slash. Whatever in the left side of the slash you are writing, that is considered as input, and whatever you are writing in the right side, that is considered as output. In case of Mealy FSM. OK. So we need to write the output. Now for A, we have considered the input of 0. What is the output in this case? 0. Why? Because this is not the sequence whatever we want. We want the sequence of 1 0 0 1. However, here only 0 is detected. So that's why output is 0. Now, if you come from A to B, what it is detecting? It is detecting 1. Is it the sequence we want? No, till now it is no. Now, if you come to C, what is it detecting? It is detecting 1 0. Because if you can remember, for C in the square box, we have written 1 0. 1 0. Is it our required sequence? No. We want the sequence of 1 0 0 1. So it means output is 0. Now you come to D. So D is detecting, if you can remember here, 1 0 0 was detected by D. 1 0 0 was detected by D. Is it the sequence we want? No. So that's why output is 0. Now you see this path. Closely see this path. From here to here. 1 0. So 1 0 0 0. Is it the sequence we want? No. So that's why output will be 0. Now check this path. The path is 1 0 0 1. Is it the sequence we want? Yes, the sequence was 1 0 0 1. So that's why here the output will be 1. Understood? So in this case, the output will be 1. OK, and here the output will be 0 if you follow this path. OK, so our state diagram is done. Now we need to do the second step for this problem. The second step is we need to make the state table. So step number 2 is we need to make state table. So how to make the state table? So you have to add few things in the state table. Sorry. What are the things should be there in the state table? This is present state. Then you should have input. You should have next state. You should have the output Z. So for input, we can use X, capital X, to represent input variable, and Z, suppose this we are using for output. Okay, output variable is represented by Z here. OK. So for each of the state, you need to consider two input, you know. So each of the state you need to write two times. A, I am writing 2 times. Likewise, B also you need to write 2 times. Then C also you need to write 2 times. D 2 times. Why? Because each of the time we have considered input of 0, input of 1, 0, 1, 0, 1. Now you need to decide what will be your next state if the input is 0 or if the input is 1. So if you see in the state diagram, try to understand what I'm saying. If you have the state of A and the input is 0 and the input is 0, where you are going? Again, you are coming back to state number A. So it means the next state will be A. Now, if your present state is A, if the input is 1, where you are going? You are going to state number B. Fine. So for B also you can do the same thing. Suppose you are in B state. If you have the input of 0, where you are going? You are going to state number C. If you have the input of 1, where you are going? You are going to the B state again, because it's a self loop. Oh, here you need to write the output of 0 because this 1 1 it is detecting. This is not the sequence whatever we want. So the output is 0. So in the right side of 1, the slash form you can write 0. OK, fine. Now for C also you do the same thing. If you have the state of C, if you have the input of 0, where you are going? You are going to D. If you have the input of 1, I didn't write this one. I forgotten to write this one. If you have this input of 1, where you are going? From C to B you are going. And you need to remember one thing. For this one also, what is the detector sequence? 1, 0, 1. Is it the sequence we want? No. So the output is 0. That we have to write. I forgot to write these things when I was making the state diagram, that you need to write. Okay. Fine. Now for D also you do the same thing. Now if you can remember for D, whatever may be the input, it can be 0, it can be 1. You have to come to state number A. So write it here. Now output, if you can remember, here the outputs are 0 except the last case when the input was 1. If you can remember, if you follow this path, this path, 1, 0, 0, 1. So that's how you got the output of 1. And that is only you need to write here. This is the 1. Okay. Now, if this state diagram and state tables are clear to you, then most of the things you have understood. Now, few things left that we need to do now. Okay. So what do we need to do? Yeah. Now, each of the variables, whatever we have used for the state representation, that has to be replaced by some binary values. Okay. So what are the values? So for this current problem, how many states are there? You know how many states are there? 4 states. State A, state B, state C, state D. So how many bits you need to use to represent each of the state? Definitely 2 bits. Why? Because using 2-bit, we can generate 4 different combination. And in this problem also 4 different combination or 4 different states are there. So that's why we need to use 2 bits in each of the case to represent each of the state. Okay. If the number of states are suppose 6 or 7 or 8, in that case, you have to use 3-bit, because using 3-bit only you can make 5 combinations, 6 or 7 or 8 combinations. Okay. Fine. Now, after that, what you have to do? Now you replace these variable values by this binary values. Okay. So you do this step. Step 3, replace this variables by the binary values. So if you can remember, in present state, you had AA, then we can write the input also. The next state. Then few things also I'll later write later on, and here output. Output is Z. Input is X. Now, as each of the state is represented by 2 bits, so in the present state we can write 2 bits. This Q1, Q0. Input is X. Next state also we can write Q1 plus Q0 plus, and Z I already written. So each of the thing is represented by some variable. Okay, so if you can remember, first one was A. So A has to be replaced by 0, 0. Okay, B has to be replaced by 0, 1. C has to be replaced by 1, 0. D has to be replaced by 1, 1. Fine. So you had input 0, 1, 0, 1, 0, 1, 0. Now, in the first case, the next state was 1. The next state was A. So A means you have to use 0, 0. Use 0, 0. Then it is B. B means 0, 1. So like that, you replace all the variables by these values. Then you have 1, 0, 0, 1, 1, 1, 0, 1, 0, 0, 0, 0. Okay. And what are the outputs? 0, 0, 0, 0, 0, 0, 0, 1. Okay. Now in this problem, if you can see how many bits are there, 2 bits are there. So to design this FSM or finite state machine, how many flip-flops are required? Definitely 2 flip-flops. Why 2 flip-flops? As you have 2 bits and each of the flip-flop can store 1 bit. So definitely you have to use 2 flip-flops. Suppose we are using JK flip-flop to implement this circuit. So how many such JK flip-flops are required? 2 JK flip-flops are required. Why? Because you have 2 bits in the representation. So you can write it down. J1, K1 is first JK flip-flop, JK flip-flop number 1. Then you have the JK flip-flop number 0, that is J0, K0. So how many JK flip-flops have you used? 2. Now you need to determine the values of these J and K. Now for that, what you need to do, for that you have to use excitation table. Excitation table of JK flip-flop. Okay. What is excitation table of JK flip-flop? You can remember if your present state is Qn, next state is Qn plus 1, what should be the value of J and K? That you need to determine. So if you know 0, 0, 0 x, 0, 1, 1 x, 1, 0 x, 1, 1, 1 x 0. This is the excitation table of JK flip-flop. So using these things, we'll replace these values. Okay. Now, this is present state is Q1 and next state is Q1 plus. So 0, 0 means you need to write 0x. Why I'm writing in the first JK flip-flop? Because I'm considering the first bit. Okay. If you consider the 0th bit, you have to use these values. You need to determine these values. Okay. Now, likewise, the 0, 0 means 0x, 0, 1, 1x, 0, 0, 0x. So likewise, you can write all the values. It's x0, x1, x1, x1. Now do the same thing for the 0th bit. Take this bit and this bit means 0, 0. You can determine here. So 0, 0 means 0x, then 0, 1, 1x. Or likewise, you can write all the values x1, x0, 1x, 1x, x2, x1. Fine. Now our job is almost done. What we need to do now? We need to find out each of the expression. So what are the expression we need to find out? We need to find out expression for Z, that is output, then J1, K1, J0, K0. All these things we have to find out. How? By using KMF. Simple. So I will show one of these KMFs. How to find the expression for each of the output variable. So that is J1. First of all, I will show. So in this case, what are the inputs? The inputs are Q1, Q0, and this X. Means in order to make this KMF, what are the input variables? You need to consider Q0, Q1, and X. Okay. And these are the outputs you need to find out. Output expression, that is Z, J1, K1, J0, K0, you need to find out. Okay. So see this table, this 0, then 0, then 1, then 0, then don't care, don't care, don't care, don't. Okay, so from this we can make a combination of these two. So what will be the expression for J? That is Q0 X bar. Okay, so likewise we can do the same thing for K1. Q1, Q0, X. So see the K1 column. These are the values. X, 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 X. Means don't care, don't care, don't care, don't care. Then you have 0, 1, 1, 1. 0, 1, 1, 1. Okay. Now in this case, we can make this quad. So this expression of K1. So if we make this quad left side and from top side, what we are getting X. And from this quad, what we will get from this quad, we are getting this 1, 1 means Q0. Okay, so likewise, if you make the other 3 KMFs, what expression you are going to get, I'm writing here. So J0, if you follow this process for J0, you'll get Q1 plus X. For K0, you'll get Q1 plus X bar. And likewise for Z also, you'll get in Q1, Q0 and X. So these are the expressions we are going to get by following this process. Now, finally, what we need to do? We need to design the circuit. So how to design the circuit? You know how many flip-flops you need to use? 2 flip-flops, 2 JK flip-flops you need to use. That is J1, K1, Q1 output, Q1 bar output, and you have J0, K0, Q0, Q0 bar. Fine. Now, what you have to do, find the expression of J1, that is Q0 X bar. So suppose that is J1. J1 is Q0 X bar. That's the AND relation, and gate you need to use Q0, I can write X bar. Okay, ideally what you can do from Q0, you can make a line, you can connect it here, but if you do so many connections, then this circuit will look so much complicated. So that's why I'm writing separately variables here. So if you want, you can do that also, but in that case, circuit will look more complicated. Oh, so that is for J1. What about K1? K1 expression, if you can remember, K1 is X plus Q0. So right here, X plus Q0 means you have to use one OR gate. Drawing is not good. This OR gate, you have X, you have Q0. Fine. So likewise for J0, what was the expression for J0? That is Q1 and X. So that is OR gate. Then for K0, you have X bar and Q1. X bar and Q. These are the inputs and these are having OR relation. Then after that, finally Z. So Z is the output variable, that is Q1, Q0X. So that was Q1. So you can take one line from here, Q1, Q0, and you can take one variable input X, and you can use one AND gate. That is your set, and this is the output. Fine. And third input is X. Okay. And one more thing you need to do, you need to give clock to each of the field. This one. The clock. Fine. Okay. So these steps you need to follow to design this particular sequence detector. Okay. Thank you.